Okay, next example. A random sample of prison inmates was selected and checked for the number of filled cavities. 7, 6, 5, 10, 9, 8, 15, 10, 10, and 10. Could this sample represent a prison population whose mean was 9.50? Okay, so once again, we know that we're working with a one sample t. So let's go ahead and write down the formula that we are going to need. So t equals the mean minus the mu over the standard error of the mean. Now, looking through the problem, we are not given the standard error of the mean, so we are going to have to use one of the secondary formulas to figure it out. The standard deviation is not given, so we are going to have to use this formula here. So the standard error of the mean equals over n minus m squared over n minus 1, and then all of that is square root. Okay, there we go. Okay, so now that we have that done, what do we need to fill out these equations? We need the mean, we need the mu, we need the standard error of the mean, we need an n value, we need the ex squared value, and then we will also need a t value at the end. Okay, so let's take another look at the problem and see what information is given to us. A random sample of prison inmates. Okay, it doesn't tell us how many, so let's count how many raw scores we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so our n value is 10. And we have a prison population whose mean was 9.5. Okay, that's going to be our population mean, so that is 9.5. And it looks like that is all the information that we are given. So, okay, so we need to figure out our mean, and we need to figure out the sum of squares here. So let's go ahead and make a list of the filled cavities that we have. So we have 7, 6, 5, 10, 9, 8, 15, 10, 10, and 10. Okay, so in order to find our mean, we need to add all those up and divide by how many we've got. Okay, so when we add all of these up, that is going to give us 90. Okay, so when we plug that into here, 90 divided by our n of 10 is going to give us a mean of 9. Okay, there's that. Okay, so now let's figure out the sum of squares. So to do the sum of squares, we are going to have to square all of these and then add them up. Okay, so 7 squared is 49, 6 is 36, 25, 100, 81, 64, 225, 100, 100, and 100. Okay, let's just go ahead and draw a line there to separate those two. Okay, so then once again, we need to add all of these up. So when we add all these scores together, that is going to give us 880. Okay, so that is good. We can go ahead and erase all of that. Okay, so now we have everything that we need to figure out our standard error of the mean. So let's go ahead and figure that out. So standard error of the mean, so just plug in those values. So our ex squared value is 880. That is going to be divided by our n value of 10 minus our mean, which is 9 squared, divided by our n value again, which is 10 minus 1, and then all of that is square root. Okay, so 880 divided by 10 is going to give us 88. 9 times 9 is going to give us 81. Then 10 minus 1 is 9. Okay, so just keep solving that. So 88 minus 81 is 7. going to divide that by 9. So 7 divided by 9 is 0.777, and that keeps repeating. So we need to round that to 0.78. Okay, and then we just need to figure out the square root for that. That is going to give us 0.8831, and we are rounding to here. So our standard error of the mean is going to be 0.88. Okay, next let's go ahead and figure out our t-score. Okay, so t equals, let's just plug those values in. The mean is 9. The mu is 9.5, and then we have our calculated standard error of the mean of 0.88. Okay, so 9 minus 9.5 is a negative 0.5 divided by 0.88. Then you're going to divide that out, and that is going to give you a negative 0.5681. And then we need to round. So our t value is going to be negative 0.57. Negative 0.57. Okay, last part, home stretch. Okay, so let's take our t value and see if we can accept or reject HO. Okay, so we are looking for t of 0.05, and then our t of 0.01. Okay, so we need to put our degrees of freedom in here. Now the degrees of freedom, if you remember, is n minus 1. Our n value here is 10 minus 1, so that's going to give us 9. Okay. All right, so let's go ahead and pull out our sheet here. And this is the level of significance for two-tail test sheet, okay? Look down the far left for your degrees of freedom of 9. Okay, so for the 0.05 level, we have 2.262. And then for the 0.01, we have 3.250. Okay? Now, right away, you can tell that you are going to have to accept HO because this is a negative value and this is not bigger than any of these values. But just for the sake of repetition, let's go ahead and do the thing. So negative 0.57, is that greater than 2.262? No, it is not. Negative 0.57, is that greater than 3.250? No, it is not. So we accept HO. And then if you want to do the graph, we will put 2.262 and then 3.250. So this would be the reject at 0.01. This would be reject at 0.05. This is accept. And our t value is negative 0.57. So that's way over here. So once again, we accept HO. And even another third method to doing this is mark on your number line here. We've got 2.262, and then we have 3.250, and this is the 0.01 reject. This is the 0.05 reject, and then all of this over here is the accept. Okay, and then we just mark it on our number line. 0.57, the negative. Okay, so that means that we accept HO. Congratulations, you did a one sample T. Good job, guys.